The question says two bodies have masses in the ratio 3:1. They experience forces which impact to uh, the experience forces which impact the acceleration is in the ratio 2:9 respectively. We're to find the ratio of the forces the masses experience, right? A, we have 1:4. B, we have 2:1. C, we have 2:3. And then D, we have 2:5. Okay, from the question we read, the first slide, we were told that two masses together, and they are the mass of each of the body. All right, two bodies are together, and the mass of each of the body of the ratio 3:1, and then their acceleration of the ratio 2:9. So we have to find the ratio of their forces. I mean, like, we have to be very, very attentive. All right. Sometimes the questions are technically asked. You need to understand the basics to be able to resolve that. So the first and foremost thing we'll do is let the mass of the two bodies be m, right? And then the acceleration, right? Also let the acceleration of the two bodies be small letter a. Okay, generally we know that the formula for force, want to calculate the force is mass. We have force F is always mass times acceleration. Now all of these are foundations of the question, and they will help us. So let's deal with case one. All right, so the mass of the first body m1, we're told that the ratio, all right, ratio of mass. So ratio of masses of the two bodies. For the first body, call it m1, all right, sorry. Ratio of the masses, we're told, is equal to 3:1. So total ratio here, all right, is equal to 4. So the mass of the first body is going to be 3, because that's the first body. This is referring to the first body. 3 over the total ratio of the entire mass. So in the same way also, for the second body, is going to be 1 over total ratio of the entire mass of the bodies, the two bodies. So ratio of acceleration, all right, we're told that the ratio of acceleration is 2:9. Is 2:9. So acceleration of the first body would be 2, and 2, of course, we know that the total ratio is equal to if you add this to this, is equal to 11. All right, so the acceleration of the first body will only be 2 over 11 of the acceleration of the bodies together. In the same way, for the second body is 9 over 11 of the total acceleration. All right, so since we know that generally force is equal to mass times acceleration, so the force of the first body will be the mass of the first body times the acceleration of the first body. So if you do that, you're going to have your F1 equals 3 over 4 of mass, all right, times its acceleration is 2 over 11 of acceleration. So the same way also for the second body, we have m2 times second acceleration, which provides that our f2 is equal to 1 over 4 of the mass of the two bodies times the acceleration is going to be 9 over 11 of the total acceleration of the both bodies combined. Now, this analysis is supposed to help you understand how to deal with each section per time, right? And if you are following along, you know that it's very interesting to resolve a very technical question of this nature. Right? So what they're asking for is the ratio of the first body to the second body. So you put these values and then simplify. That's going to give us this is the value for F1. All right. So F1 we will have 3m over 4 times 2a over 11, all right, all divided by, you have m over 4 times 9a over 11. All right, so if we simplify this, all right, we have to do interpolation here. All right, this has to go up, or what it simply means is that we have 3m times 2a, that's going to give you 6ma. And if we have 4 times 11, that's going to give you 44. Then divided by, if you multiply this by this, that's going to give you 9a over 44. So if we do that, our F1 to F2 is going to give us 6ma over 44 times, we have 44 over 9a of 9ma, because if you interpolate, that's going to go up. All right, sorry, this is going to be times ma. All right, so we have a 9ma. So ma will cancel ma, 44 will cancel 44, and the result is equal to 6 6 divided by 9, which is the same thing as 2 divided by 3. Therefore, all right, the final result, F1 to F2 is equal to 2 to ratio 3. And then you almost just can deduce what the answer will be. C, because that's where we have 2 to ratio 3. All right.